Hi everybody, I'm going to talk about resonance a little bit more in this video. So I'm mostly going to be using and kind of demonstrating the patterns that we talked about in the last video and in class, just to kind of see, so you can see how to use these patterns in a larger system where we've got more things going on, more directions that the resonance can be going, and kind of picking up on what that tells us about the structure overall. Because resonance is really good at telling us, how to identify reactive sites. And when you just look at this, you see this positive charge and think, oh, well, that's an area of low electron density. But there's actually multiple areas of low electron density in this molecule because it's kind of spreading that charge out. So the whole point of resonance is to be able to find those points. So I'm going to do all the resonance structures and then we're going to finish off with the resonance hybrid. Okay, so whenever you want to delocalize a charge, just start by looking at what that charge is connected to. So you're really looking at any carbons or other atoms besides H that have some sort of pi bonds around. So in this case, I have pi bond here, pi bond here. I can take either one of those options and go ahead and start from there. So I'm going to decide to start from the right. You could start from the left. It makes no difference at all. Okay, so I'm going to use that pi bond, push it over to make a new pi bond. Again, I like to draw out the sigma bonds first. That pi bond is now there, which means my positive charge has now moved. And I would say, if you're still working on getting used to this, never a bad idea to draw on the hydrogens here so you can find your partial charges easier. Okay, so once you're here, then basically what you have is a whole nother resonance problem where you ask yourself, okay, this is where my charge is. I'm going to look at these atoms that are attached to it. So in this case, I have the pi bond, which we've already done. So if I go back that way, I'm going back to this. But I also have lone pairs on this oxygen, right? So in these two, we essentially have the pattern of carbocation next to pi bond, and in this one is lone pair next to pi bond. So we can go ahead and share that lone pair. So if I'm trying to do this color coordinated, share the lone pair. Okay, so now I've got a double bond here. I still have one lone pair on the oxygen. That makes that positive. Still have the pi bond over there, and then all of the things on this side have not changed. So it's really important to be really careful when you're drawing these things out that all of this stuff doesn't change, right? Anything that doesn't have an arrow to it should not be changing at all. All right, so let's, at this point, that positive charge, we're kind of stuck there. We don't really have anything else that we can do with it. But we did have two options back at the beginning. So let's go ahead and do the other option. I'm going to use orange for this one. So I could have also gone that way, right? I could have taken one of the double bonds in the ring here and used that. So that means that I'm going to have my positive charge right here, because this is the carbon that I took electrons away from, right? I've got one H there, one H there. Okay, so then now we look at this positive charge, we look at what's connected to it. So I've got this pi bond or this pi bond. Again, doing this one would get me right back to where I started. So let's go ahead and do that one. Again, being very careful not to change anything that I didn't have arrows to or from. Okay, that ends up with a positive charge right here. So it may be tempting to try to use this pi bond at some point, but it's going to be impossible for us to get that positive charge on this carbon to allow us to do that. So we actually can't do anything with it. It's just going to sit there. All right, so now oops, we're at the positive charge here, we've got connections with these atoms, remembering that that nitrogen has a lone pair. Let's go ahead and use that nitrogen lone pair. Okay, that's now positively charged. Again, we're looking at the fact that I've got one positive, one positive, one positive, one positive. So my overall charge, again, is not changing at all. If it's changing, something's going wrong. Okay, so now with my charge here, I can go back. That's going to get me here. So this is where sometimes doing multiple arrows can help. If you know that this is going to get you here, and then at that point you could do this, then you can just do them all at the same time. Okay, so you can say, I'm going to take that pi bond, move it onto the nitrogen as a lone pair, and then I'm going to go ahead and move that other pi bond over. So that I end up here. Okay, so just to kind of look at this again, if we look at how our benzene ring started, right now our pi bonds are shifted one over. So if I do another arrow here, I'm actually not quite getting to the same exact structure. I'm getting to a resonance structure of it, where now I have my pi bonds slightly offset. Oops. So I end up here. Okay, so it's almost like how I started, but if you look at the pi bonds here versus the pi bonds here, they are shifted one over. Okay, so then if we want to draw the resonance hybrid, I find the easiest way to do this is just to start off with all of the sigma bonds in place. Okay, so once we have all the sigma bonds, then we can go ahead and start adding in all of our partial bonds and all of our partial charges. So basically what you're looking at is anytime that you have a pi bond that moved, you put a dashed line. In this case, this pi bond did not move. So that one is going to stay the same. So if we look at all of the other places, so this chain got pretty well worked through, right? So if you compare those will all be dashed. Okay, our oxygen at one point had a positive charge on it, so oxygen gets a delta plus. We also are going to be putting a delta plus on these two carbons from those. So delta plus, delta plus. Okay, we have full delocalization around our benzene ring. So we have dotted lines all around that. And we were able to put positive charges here, here, and here. Okay, we have here, here, here. And then we also had our nitrogen get involved. So we had a little double bond there and a delta plus on the nitrogen. Okay, so if you look at this resonance structure, we are effectively sharing that positive charge over 1, 2, 3, 4, 5, 6, 7 atoms. Okay, it's not just stuck on one. All right, so let's look at a version with a negative charge. So negative charge, you're using a lot of the lone pair next to pi bond pattern. So again, we have kind of two options that we can go for. I'm going to go for the one on the right first, but again, does not matter, whatever your preference is. Oh, why did I make this so long? Okay, so then we end up here. Now at this position, oops, I'm missing one. There we go. I was missing this arrow to make a pi bond right there. Okay, so this negative charge is next to this pi bond, so I can go another one. Okay, making that oxygen negative, still keeping the negative charge, still keeping my pi bonds. So this, because it's sp3, we can't do anything with it. We're stuck. But we can go back to this structure. We could have gone this way. Okay, to get here, we can keep on going. Again, we've got that pi, that lone pair to pi bond, and then the pi bond to the lone pair. Okay, so then we end up here, one final one, same exact pattern. And then we end up with that final resonance structure. Okay, so again, one charge throughout the whole thing. We're going to focus on delocalizing that. Let's go ahead and draw out the hybrid. So the hybrid is going to look something like this. Again, we're just going to focus on sigma bonds at first. Okay, so that's all my sigma bonds. We were able to delocalize all around here, all here, and up to that oxygen. Okay, we were able to put delta minus there. I'm going to have to look back at this a little bit. Delta minus, delta minus, delta minus, delta minus, delta minus. Okay, so you can double check me if you want, but I also know that there's a pattern here with negatives. They go every other. It's a little trick. So minus, 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 minus. You can kind of see how they troop along at the top or the bottom. So that's kind of how to use those patterns, and you'll start picking up more and more as you go. But those are the basic ones. Again, let me know if you have any questions, and I will see y'all later.